Today, we're going to dive into a really powerful idea, one that kind of challenges the way we've been thinking about using AI to tackle the climate crisis. It's not just about building faster or more powerful tools. It's about asking if we're building the right kind of intelligence for a planet that's, alive and fundamentally unpredictable. This quote, man, it just gets right to the heart of it, doesn't it? It perfectly sets up this core tension. Are we trying to build AI that gives us a neat, clean dashboard view of the world? Or are we building it for the messy, complex, interconnected reality of a living system? Are we designing for simplicity, or are we designing for resilience? So, to really get a feel for this tension, let's start with the incredible stuff that's happening right now. AI is kicking off a genuine revolution in how we model our planet, and weather forecasting is ground zero for this change. I mean, just look at this scale of this leap. It's staggering. We're talking about Google's GraphCast, which can whip up a 10-day global forecast in less than a minute. Or Microsoft's Aurora, which just blows past the old models on over 90% of the metrics. This isn't just a small step up. It's a total game changer. So you see that kind of speed, that kind of accuracy, and the conclusion feels pretty obvious, right? We've got this amazing new tool, and it seems like it's perfectly built to help us navigate the climate crisis. But there's a catch. And this is really the pivot point of our whole conversation. Before we just race ahead and apply this new power to everything, we've got to stop and ask a much deeper question. Is the kind of intelligence that's great at short-term prediction, is that the same intelligence we need to build a healthy planet for the long haul? And that question leads us directly to this concept called the monoculture trap. It's this idea that our obsession with getting a single, clear, confident answer from AI could actually make us more fragile, not more secure. Okay, so here's a core idea. Most AI is trained to take all this messy, complicated possibility and just collapse it down into one single coherent story. Think of it like a giant farm that only plants one type of high-yield corn. Yeah, it's super efficient when the conditions are perfect, but one new disease, one bad drought, and the whole system collapses. Our thinking itself can become just as brittle. This really lays out the two different paths, right? On the left, you've got that AI monoculture, narrowing everything down to one optimized answer. But on the right, you have what you could call ecological intelligence. It thinks more like a thriving forest. It keeps a ton of different options open so it can stay resilient. It doesn't try to predict one future, it gets ready for many possible futures. And this is such a critical point. The risk here isn't necessarily that the AI is going to be wrong. The real danger is that it's going to be so confident, so persuasive in telling one single story that we all just stop even thinking about any other possibilities. It all boils down to two different ways of knowing things. These new weather AIs, they are absolute masters of pattern recognition, learning from mountains of past data. But climate change, by definition, is creating conditions that have never happened before. And that's where you need process understanding. You need to model the fundamental physics of how a system works. That's what stays robust when things get weird. Pattern recognition is fragile. Process understanding is resilient. So if that's the problem, where do we look for a better model? Well, it turns out nature and climate science itself have already figured this out. They run on a logic of resilience, not just pure efficiency. Just think about the big IPCC reports on climate change. They never give you just one prediction. Instead, they create what they call an ensemble. It's basically a whole family of different models that map out a huge range of plausible futures. The goal isn't to find that one certain answer, it's to understand the entire landscape of what could happen. And this is exactly how a healthy forest works. It has tons of different species, so some trees can handle a drought while others thrive in wet years. It has redundancy, backups for its backups. It doesn't optimize for last year's weather. It keeps its ability to adapt to whatever comes next. That diversity is its insurance policy. So this is where it all comes together. We need to shift the entire job description we've given to AI. Instead of just asking it to forecast risk, we need to start using it to help us actively build resilience, to help us regenerate our living systems. And if you want an amazing real-world example, look at China's Loess Plateau. It was once one of the most degraded landscapes on the entire planet. The project to restore it didn't just follow some single rigid plan. Instead, they created a feedback loop. They'd intervene, they'd monitor the land's response in real time with data, adjust their strategies based on that feedback, and over time,
The whole ecosystem came back to life. That is regenerative intelligence in action. So to put it as simply as possible, forecasting is great at mapping out the risks, and we absolutely need that. But regeneration is what actively builds our resilience to face those risks. They're two different jobs, and it's time we get really serious about the second one.
Okay, so what does this actually look like? How do we build this new kind of AI? Well, here's a blueprint built on 6 key principles. First up, preserve diversity before you try to optimize. Don't just find the one best option, show us lots of good ones. Second, make uncertainty visible. Don't let the AI pretend it's certain when the data is thin. Show us the gaps. And third, build for continuous feedback. The whole system should be designed to constantly learn and adapt, just like on the lowest plateau. Number 4, we have to prioritize long-term stability over short-term wins. 5, distribute the intelligence. Instead of one giant centralized model, let's empower local communities with tools they can use. And finally, number 6, design for regeneration. Make the AI's goal to actively help restore our ecosystems and build our capacity to adapt. And this all leads to the final, and maybe the most profound idea here. The choices we're making about how to design AI today aren't just small technical decisions. They're going to have huge long-term consequences for everyone. Because what we're building right now, it's more than just tools. We are literally constructing the cognitive infrastructure that future generations are going to use to understand and interact with their own planet. We're shaping how they will see risk, how they will make choices, and what solutions they will even think are possible. So the final question is really for all of us. Are we going to build an AI that gives us that brittle, clean certainty of a dashboard? Or are we going to design an intelligence that actually mirrors the diverse, adaptive, and resilient logic of a living planet? That's the choice we're making right now.